Okay, we're going to start with Chapter 8, Further Kinematics, last mechanics unit that you're going to do. And we are going to go straight in and look at example 1. So further kinematics is all about doing movement but with vectors. So everything you did last time when you did SUVAT in year 12 was one-dimensional. We looked at some two-dimensional stuff with projectiles, but now we're going to do the more generalised form of two-dimensional. So it's not a projectile, it's not got gravity, it's not got that horizontal acceleration. Right, it's going to be slightly different. The first thing that we need to know, right, is this formula, which is that if you've got a particle and you want to know where it is, so in this we're saying that r is the position of a point. Then we've got that r equals r0 plus v times t, right? Where r0 is the starting position, v is the velocity, and t is obviously the time. So in all our calculations we're going to do in this unit, generally things like positions, speed, acceleration will be vectors, whereas time is always going to be a number, right? We don't get a vector of time, do we? We just always keep that as a constant. So this is the overall position we're given by this formula. So if we look at example 1, we're just going to apply that formula in a very basic form. So what we've got is it starts, so that's r0 is 3i plus 7j. That's the starting position if you want to imagine that on a coordinate grid. And it moves, so that's the velocity that's constant, 2i minus j meters per second. And it asks the position, so the position is r, that's what we're looking to find, and it tells us that the time is 4 seconds, right? So all we're going to do is we're going to pop into that formula there. R is the start plus the velocity times the time. So I've got that r equals, and what I'm going to do is I'm going to do this throughout this unit, is we're going to generally use the column vector form. So if we use the column vector form, everything is going to look a lot simpler to us. Okay. Right, that would be in column vector, so this is your r0, 3, 7. This is your v, 2 minus 1, 2i minus j, and the time is 4. So you can see how everything's going to be a vector except for that time, which is just a number. So now all we do is we times each of these by 4 and we add it to that. So 4 times 2 is 8, plus 3, 11. 4 times minus 1 is minus 4, plus 7 is 3. So r is 11, 3. So that's the location of the particle after 4 seconds. Again, seeing this question, put it in that I and j format, we can put it back in that I and j format as well there. Then says find a time at which the particle is due east of the origin. Okay, so if it's due east, what we've got to think about there is what that means. So if we think about a little diagram here, so this is the j direction, this is the I direction, and if we're due east, aren't we? We're somewhere, right? We're somewhere on this line here. And the important thing is that if we're just east and we're not north or south at all, then that tells us that the j component, so the j part, is going to be equal to 0. Alright, so what we need to do, coefficient of j is equal to 0, is we need to set up our equation. So what we're looking for is the time. So we know when we do it at the position, r is going to be equal to 3, 7, which was the start, plus the velocity multiplied by the time. But the key point is that the j component has to be equal to 0. And the j component we get from doing 7 plus minus 1 times t. So for that to be equal to 0, we've got to have that 0 equals 7 plus minus 1 times t is minus t, so t is 7 seconds. Okay, so that's because for us to be due east is when the j part is 0, so the bottom of my vector equation has got to be 0, so that's how we find t. Pull that equation out of there, we get that it's 7 seconds.